Hi friends, welcome to Naresh IT Technologies. This is Srinivas. Today let us discuss a concept called pipes and cisterns. Now this pipes and cisterns is the continuation of the topic time and work. All the concepts and logics used in time and work we use in this chapter called pipes and cisterns. Now what is a cistern? Cistern is a tank. Generally in time and work, we see that all people work together to complete the work. There is no person who will destroy the work. But in pipes and cisterns, we have a destructor called emptying pipe. Generally, a tank has two types of pipes. One is a filling pipe, the other is an emptying pipe. Now, let us talk generally about this topic. See, suppose there are two friends who are doing a work. The first person, he is constructing a wall and the second person is destroying the wall. Now what happens ultimately? Now there are two things that can happen. One is the wall can be constructed. The second one is the wall can never be constructed. Now when will the wall be constructed? If the efficiency of the constructor is more than the efficiency of the destructor. Now when will the wall be never constructed, or when can the wall never be constructed? If the efficiency of the destructor is more than the constructor. Now this is the basic logic point we use in this chapter to solve the problems. Definitely the work here is either to fill a tank or empty the tank. If you want to fill a tank, filling pipe efficiency should always be more than the emptying pipe efficiency if these two pipes are working together. If you want to empty the tank, definitely emptying pipe efficiency should always be more than filling pipe efficiency. Now this is the simple logic we use in solving the problems. If a filling pipe fills a tank in 20 minutes, but if there is an emptying pipe, definitely to fill the tank it takes more than 20 minutes. Now why will it take more than 20 minutes? Definitely because it has to do some work extra than what it has to do, because some work will be destroyed by the emptying pipe. Now using this simple logic, let us try to solve some basic problems initially and then go for the advanced problems in this chapter. Now let's start with one basic problem in this chapter. A filling pipe A can fill an empty cistern in 12 minutes. How much part of the tank will it fill in 4 minutes? Now looking into the solution for this simple basic problem. A filling pipe can fill an empty cistern in 12 minutes. So how much part of the tank will it fill in 1 minute? In 1 minute, the pipe will fill 1/12 of the tank. If in 1 minute it fills 1/12, now let us try to understand what do you mean by 1/12. If you divide the total tank into 12 equal parts, in 1 minute it fills 1 part. Now how much part of the tank will it fill in 4 minutes? In 1 minute, if it fills 1 part out of 12 parts, in 4 minutes it should fill 4 parts out of 12 parts. So in 4 minutes it fills 4/12 of the tank, which is 1/3. So the pipe will fill 1/3 of the tank in 4 minutes. Now this is a basic problem which we use to solve a higher level problems. Now let's take one more example, basic example to solve this problem. Second problem, a filling pipe fills 3/5 of the cistern in 12 minutes. How much time will it take to fill the complete cistern? the pipe fills 3/5 of the cistern in 12 minutes. That is, if you divide the cistern into 5 equal parts, to fill 3 parts, it takes 12 minutes. How much time will it take to fill the complete cistern? That is, to fill 5 parts, how much time will it take? So, simple solution is, to fill 3 parts, the pipe takes 12 minutes. To fill 1 part, the pipe should take 4 minutes, and to fill 5 parts, the pipe should take 20 minutes. 5 into 4, 20 minutes. So, to fill the complete cistern, the pipe takes 20 minutes. Now, let us discuss the next question in this chapter. The next question, 2 filling pipes A and B can fill an empty cistern in 20 minutes and 30 minutes respectively. Both the pipes A and B are opened together, but after few minutes, pipe A is closed. After how many minutes is pipe A closed if the cistern is full in 24 minutes? Now, let us first of all try to understand this question. Now, if you look into this question, in this question, we have both filling pipes. So, there is no destructor in this problem. So, this problem is similar to time and work. Now, let us solve this problem after analyzing it. It is given both the pipes A and B are opened together, but after few minutes, pipe A is closed. So, which pipe is operated from the first minute till the last minute? Obviously, it is pipe B. And it is given in the question that the cistern is full in 24 minutes. So, definitely pipe B is the pipe which is operated for all 24 minutes. So, from this given information, we can find out how much part of the cistern is filled by pipe B, and from that we can find out how much part is filled by pipe A. Now, let us solve this problem. How much part of the tank will pipe B fill in 1 minute? In 1 minute, pipe B fills 1/30th of the cistern. Now, this pipe B is for all 24 minutes. In 24 minutes, how much part of the tank will be filled by pipe B? In 1 minute, if it fills 1/30th, in 24 minutes, it should fill 24/30th, which is 4/5. Now, if pipe B has filled 4/5 of the cistern in all 24 minutes, but in the question it is given that tank is full in 24 minutes. Now, which pipe has filled the other part? Obviously, the other part is filled by pipe A. Now, let us talk about pipe A. So, pipe A has filled 1/5 of the tank. That is, out of 5 parts, if pipe B has filled 4 parts, out of the same 5 parts, pipe A has filled only 1 part. Now, to fill that 1 part, how much time will pipe A take? So, time taken by pipe A to fill 1/5 of the tank will be 1/5 into 20, which is 4 minutes. So, pipe A is opened for 4 minutes, or we can say pipe A is closed after 4 minutes. Now, if you look carefully into this problem, each and every statement is interlinked. Now, I need to find out for how many minutes is pipe A opened. For that, I need to find out how much part of the tank is filled by pipe A. For that, I must know how much part of the tank is filled by pipe B. For that, I must know for how many minutes is pipe B opened. So, if you look into the solution once again, pipe B is opened for 24 minutes. In 24 minutes, it fills 24/30, that is 4/5 of the tank. So, this is the part of the tank filled by pipe B. Then how much is filled by pipe A? It is 1 minus 4/5, 1/5. So, pipe A has filled 1/5 of the tank. So, to fill complete tank, if it takes 20 minutes, then to fill 1/5 of the tank, it should take 4 minutes. Now, let us go to the next question in this chapter. A filling pipe A can fill an empty cistern in 24 minutes and an emptying pipe B can empty the same full cistern in 32 minutes. Both the pipes A and B are opened together, but after few minutes pipe B is closed. After how many minutes is pipe B closed if the cistern is full in 30 minutes? Now let us try to solve this problem, but before that let us try to analyze the problem. Now we are given the individual information about A and B first, but A is a filling pipe and B is an emptying pipe. A filling pipe A, it can fill the cistern in 24 minutes and the emptying pipe B can empty the same full cistern in 32 minutes. Now this is the information about the two pipes A and B. Now coming to the problem. The problem is both the pipes A and B are opened together, but after few minutes pipe B is closed. Now the question is, after how many minutes is this pipe B closed if the cistern is full in 30 minutes? So now analyzing the problem, which pipe is opened for all 30 minutes? Definitely pipe A is opened for all 30 minutes. Now here the duty of pipe A is to fill and the duty of pipe B is to empty. Now based upon the given information, I can find out how much part of the cistern is filled by pipe A in that 30 minutes. In 1 minute, pipe A fills 1/24th of the cistern. That is, in 1 minute, it fills 1 part out of 24 parts. Now this pipe is opened for all 30 minutes. So in 30 minutes, how much part of the cistern will it fill? In 30 minutes, pipe A should fill 1/24 into 30, which is 5/4. So if you open pipe A for all 30 minutes, in that 30 minutes, it fills 5/4 of the cistern. Now this 5/4 is nothing but 1/4. But if you look into the question, in the question it is given in 30 minutes the cistern is full, that is one tank is full. But if pipe A is opened for all 30 minutes, it should fill one tank plus another 1/4 tank extra. Now what happened to this 1/4 tank of water? Definitely this 1/4 tank of water is emptied by pipe B. Now pipe B in 1 minute it empties 1/32 of the cistern, but pipe B has emptied only 1/4 of the cistern. So to empty 1/4 of the cistern, how many minutes will it take? Obviously it takes 8 minutes. Or directly you can tell the answer, pipe B has emptied 1/4 of the cistern. To empty one complete cistern, it takes 32 minutes. Then to empty 1/4 of the cistern, it should take 1/4 into 32, which is 8 minutes. Now this is one way of thinking to solve the problem. That is, if you want the information about pipe B, first of all you must know how much part of the cistern is emptied by pipe B. For that you must know how much part of the cistern is filled by pipe A. If you look into the solution for this problem once again, pipe A is opened for all 30 minutes. In that 30 minutes it fills 1/4 part. That means it has worked 1/4 extra. Actually it should fill only one tank, but it has filled 1/4 tank. Now why did it fill this 1/4 tank extra? Definitely because this 1/4 tank is emptied by pipe B. Pipe B, to empty one tank, if it takes 32 minutes, then to empty 1/4 of the tank, it should take 8 minutes. Now this is one way of thinking to solve the problem. Now if you still want to simplify this, you can tell the answer for this question in a simple way. Let us try to understand that method. Now the other method is, the simple logical point here is only filling pipe can fill a tank. Emptying pipe can never fill a tank. That is the logical point. Now filling pipe actually should fill the tank in 24 minutes. But in the question it is given the tank is full in 30 minutes. That means this filling pipe, instead of filling in 24 minutes, it is taking 6 minutes more to fill the tank. Now why is it taking 6 minutes more to fill the tank? Definitely because there is an emptying pipe. Now in that 6 minutes, how much part of the tank did it fill, or it means how much work did it do extra? If we can find out, then definitely you will get the answer in a very simple way. Pipe A in 1 minute will fill 1/24 of the cistern. Pipe A in 1 minute will fill 1/24 of the cistern. This pipe is working for 6 minutes more than what it has to work. So in that 6 minutes, definitely it will be filling 1/4 of the cistern. That means pipe A has done 1/4 work extra. Now why did it do 1/4 work extra? Definitely because this 1/4 tank is emptied by pipe B. So pipe B to empty 1/4 of the tank, how many minutes will it take? To empty one tank, if it took 32 minutes, to empty 1/4 of the tank, it should take. So this is how you can solve this problem. The best way you can analyze, that is, if you can analyze this problem as simple as possible, you can write down the solution in a very simple way in minimum steps. Now let us solve another problem in this chapter. A filling pipe A can fill an empty cistern in 27 minutes and an emptying pipe B can empty the same full cistern in 45 minutes. Both the pipes A and B are opened together, but after 15 minutes, pipe B is closed. Further, how many minutes will pipe A alone take to fill the remaining cistern after closing pipe B? Now if you analyze this problem, now the individual information about two pipes. A filling pipe A, it can fill the cistern in 27 minutes and an emptying pipe B can empty the same full cistern in 45 minutes. Now this is the individual information about the two pipes. Now the problem. The problem is both the pipes A and B are opened together, but after 15 minutes you are closing pipe B. Now if you look or if you analyze this problem correctly, we will come to know that the emptying pipe B is opened only for 15 minutes. So definitely from this information I can find out how much part of the cistern is emptied by this pipe B. Now let us solve the problem. Now instead of we finding out how much part of the cistern is filled by both A and B together in 15 minutes, we are going to find out how much part of the cistern is emptied by pipe B in that 15 minutes. Now pipe B in 1 minute will empty 1/45 of the cistern. So in 15 minutes pipe B empties 15/45, which is 1/3 of the cistern. So in the 15 minutes where pipe B is opened, it has emptied 1/3 of the cistern. Then how much part of the cistern should be filled by pipe A? Now a student immediately gets an idea that it should be 2/3, but actually it is not 2/3. Pipe A has to fill extra 1/3 than what it has to fill. Actually the cistern can be filled by only the filling pipe. So pipe A has to fill one tank plus another 1/3 tank extra. Now to fill one tank or one cistern, it takes 27 minutes. Then to fill 1/3 of the cistern, it will take 9 minutes. So pipe A should be opened for totally 36 minutes to fill the tank, or we can say the complete tank is filled in 36 minutes. But this is not the answer for our question. Now what is the answer for our question? If you look carefully, both the pipes A and B are opened together, but after 15 minutes pipe B is closed. Further, that is from there onwards, how many minutes will pipe A alone take to fill the remaining cistern after closing pipe B? Now in this 36 minutes, pipe A is opened along with B for the first 15 minutes. The question is, after 15 minutes, how much time did it take to fill the remaining cistern? So the answer for this question is 36 minus 15, 21 minutes. Now let us look into the alternate method of solving this problem. Now in this alternate method, we are going to use the concept called LCM. Now when I say the concept of LCM, here I assume the total capacity of the cistern. Now let us look into the alternate method of solving this problem. Now in this alternate method, as I told you, we are going to assume the total capacity of the tank, and that total capacity of the tank should be a number which is exactly divisible by 27 and 45. Now when I say exactly divisible by 27 and 45, definitely that number should be the common multiple of 27 and 45. So let us take the least common multiple, that is the LCM. Now hope all of you know how to find out the LCM of 27 and 45. I can take out 9 common, 9 3s, 9 5s. So the LCM of 27 and 45 is 135. Now I assume the total capacity of the cistern is 135 liters. Now according to the given question, pipe A, that is the filling pipe, can fill the cistern in 27 minutes. That is, it can fill 135 liters in 27 minutes. So the filling pipe A should fill 5 liters per minute, which is 135 by 27. Now the emptying pipe B, it can empty the same 135 liters in 45 minutes. So how many liters will it empty per minute? Now pipe B will empty 3 liters per minute, which is 135 by 45. Now solving the problem. Both the pipes A and B are opened together for 15 minutes. Now here the total work is to fill 135 liters. If both the pipes A and B are opened together for 15 minutes, now let us see what happens in that 15 minutes. If I open both the pipes A and B for 1 minute, A should fill 5 liters, but B will empty 3 liters. So if I open both A and B for 1 minute, in that 1 minute they will be filling 5 minus 3, 2 liters. That is, as every minute passes by, you find 2 liters of water added into the tank. Then after 15 minutes, how many liters you find in the tank? It's 2 into 15, 30 liters. After 15 minutes, we find 30 liters of water in the tank, but the total capacity of the tank is 135 liters. Now what happened after 15 minutes? Pipe B is closed. So from now onwards, the remaining part of the cistern will be filled by only pipe A. So now pipe A has to fill the remaining cistern, that is 105 liters. Now pipe A has to fill 105 liters and per minute it fills 5 liters. The question is, how many minutes will it take to fill this 105 liters? So the answer is 105 by 5, 21 minutes. So after closing pipe B, pipe A will take 21 minutes to fill the remaining cistern. Now let us discuss the next problem in this chapter. A filling pipe can fill an empty cistern in 30 minutes, but due to a leakage at the bottom, it takes 12 minutes more to fill the cistern. In how many minutes will the leakage empty the full cistern? Now if you analyze this problem, if there is a filling pipe, it can fill the cistern in 30 minutes, but because there is a leakage at the bottom, it takes 12 minutes more to fill the cistern. That is, if there is only filling pipe, the cistern will be filled in 30 minutes. But if there is a leakage, it will take 12 minutes more. That is, if there is a leakage, the cistern will be filled in 42 minutes. Now we need to find out in how many minutes will the leakage empty the full cistern. That is, when a tank is full and if you open only the leakage, how many minutes will it take to empty the cistern? Now if you want to solve this question in a very simple way, the best way is the method we have used to solve the previous problem, that is LCM method. Now here, let's first of all analyze the problem once again. Only filling pipe will fill the cistern in 30 minutes. Filling pipe and leakage, that is along with the leakage, the cistern will be filled, but it will be filled in 12 more minutes. That is, it will be filled now in 42 minutes. Now the method, LCM method, the LCM of 30 and 42, 6 5s, 6 7s. So the LCM of 30 and 42 is 6 into 5 30, 30 into 7 210. So now I assume the total capacity of the tank is 210 liters. When I assume the total capacity of the tank is 210 liters, this filling pipe will fill this 210 liters in 30 minutes. So the filling pipe should fill how many liters per minute? Filling pipe will fill 7 liters per minute. And along with the leakage, the filling pipe will fill the cistern in 42 minutes. Then per minute, how many liters are filled? 210 divided by 42, which is 5 liters per minute. Now how did you get this 7 liters per minute? It is 210 divided by 30. Now how did you get this 5 liters per minute? It is 210 by 42. Now if only filling pipe is opened, as every minute passes by, 7 liters will be added into the tank and the tank will be filled in 30 minutes. But if there is a leakage, only 5 liters will be added into the tank. So then what is this leakage doing? Definitely this leakage is emptying 2 liters per minute. Once again, only filling pipe will fill 7 liters per minute. Along with the leakage, only 5 liters are filled in the tank. That is, this leakage is emptying 2 liters per minute. Now the question is, to empty the complete cistern, how many minutes will it take? So time taken by leakage to empty the full cistern will be 210, which is the total capacity of the cistern, 210 liters, and per minute it empties 2 liters. So to empty 210 liters, it takes 105 minutes. So the leakage will empty the complete cistern in 105 minutes. Now let us discuss the next problem in this chapter. A cistern has a leakage which can empty a full cistern in 8 hours. When the cistern was full, a tap was turned on which fills water into the cistern at the rate of 5 liters per minute, and the cistern is now emptied in 12 hours. Find the capacity of the cistern. Now let us try to analyze this question. There is a cistern which has full of water in it. Now this cistern has a leakage which can empty the complete cistern in 8 hours. Now this is the information about the leakage, that the leakage can empty the complete cistern in 8 hours. Now the problem starts. The problem is, when the cistern was full, a tap was turned on which fills water into the cistern, and the cistern is now emptied in 12 hours. I need to find out the total capacity of the cistern. Definitely, to tell the answer for this question, now what is that we must know? We must first of all find out how much time will the tap take to fill the tank, because we know that the tap is filling water into the cistern at the rate of 5 liters per minute. See, for example, if I say the tap can fill the cistern in 30 minutes, then what is the capacity of the tank? Per minute it fills 5 liters, in 30 minutes it should fill 150 liters. So 150 liters will be the capacity of the tank. So to tell the answer for this question, we need to find out how much time will the tap take to fill the tank. Analyzing the problem. Actually, the leakage can empty the tank in 8 hours. But when the tap is opened, it took 12 hours to empty. That means the leakage has actually worked for 4 hours extra. So in that 4 hours, how much part of the tank can it empty? To empty one complete tank, it takes 8 hours. In 4 hours, it empties half of the tank. That means the leakage has emptied 1.5 tank of water. But there is only 1 tank of water in the tank. Now from where did you get this half tank of water? Definitely the other half tank of water was filled by the filling pipe, that is the tap. In how many hours? In 12 hours. So to fill half tank of water, if the tap takes 12 hours, then to fill the complete tank, it should take 24 hours. Then your answer will be 24 into 60 into 5. It is 7,200 liters. Now this is how you can analyze this problem and tell the answer. Now the alternate method to tell the answer for this. Leakage actually can empty the tank in 8 hours. But when a tap is opened, tap and leakage together are opened, it takes 12 hours to empty. Now in this problem, the work is to empty the tank. Only leakage can empty the tank in 8 hours. Tap and leakage, if both are opened, the tank will be emptied in 12 hours. Now I use the LCM method to answer this question. Now the LCM of 8 and 12 is 24. So I assume the total capacity of the tank is 24 liters. Now here first of all I am trying to find out how much time will this tap take to fill the tank. Now leakage will empty this 24 liters in 8 hours. So per hour it should empty 3 liters. So the leakage will empty 24 liters in 8 hours. So per hour it empties 3 liters. Now if a tap is opened, the cistern will be emptied in 12 hours. That means if a tap is opened, per hour only 2 liters is emptied. Tank is full. If I open only leakage, as every hour passes by, 3 liters will reduce in the tank. But if a tap is opened, only 2 liters will reduce in the tank. So what is this tap doing? Obviously, the tap is filling 1 liter per hour. Only leakage, if I open only leakage, 3 liters will reduce in the tank. Along with the tap, only 2 liters will reduce in the tank. So the tap is filling 1 liter per hour. So to fill the complete tank, that is The capacity of the tank we have assumed as 24 liters. So to fill the complete 24 liters, how much time will it take? So the tap will take 24 hours to fill the tank. Now what is the capacity of the tank? Total capacity. It can fill the tank in 24 hours, but we already know per minute it fills 5 liters. Now convert these hours into minutes. 24 into 60 into 5. Calculating this, we get the answer as 7,200 liters. So the answer for this question is 7,200 liters. Thank you for watching. For more videos, subscribe at www.youtube.com/NareshIT.